Welcome back to Infinity Beyond. So far, we've explored how humans measure time, how ancient civilizations aligned with celestial rhythms, and how living beings experience time biologically. But now it's time, pun intended, to leave Earth behind. Let's ask a fascinating question. What does time look like on other worlds? How would time pass if you were standing on Mars, orbiting Jupiter, or hovering near a black hole? Let's start close to home. A day on Mars, known as a sol, is about 24 hours and 39 minutes. That's not too different from Earth, which is why some space agencies like NASA simulate Martian schedules during rover missions. Engineers on Earth working with rovers like Curiosity or Perseverance have lived on Mars time, waking up and sleeping based on the Martian clock. That 39-minute difference adds up quickly, throwing off Earth-based routines and making it feel like you're slowly rotating out of sync with the rest of humanity. On Jupiter, things get strange. Despite being the largest planet in the solar system, Jupiter has the shortest day, only about 10 hours long. It spins incredibly fast, creating enormous storms like the Great Red Spot. If you lived there, and could somehow survive, your day would be more like a rapid blur. Venus, meanwhile, is the queen of weird time. It rotates so slowly that a single day on Venus lasts 243 Earth days, but its year is only 225 Earth days long. This means that on Venus, a day is longer than a year. Imagine seeing the sun rise just once every few months. Time behaves differently, not just because of rotation, but because of gravity, a concept we touched on earlier with Einstein's theory of relativity. The stronger the gravity, the slower time flows. This means that near a massive planet or star, time ticks more slowly compared to someone farther away. This leads us to the most extreme example in the universe: black holes. A black hole's gravity is so intense that time practically stops at its edge, the event horizon. According to Einstein's equations, if you watch someone fall into a black hole from a safe distance, they would appear to slow down infinitely, frozen in time. But from their perspective, they would fall in normally, while the rest of the universe speeds up. This concept was famously dramatized in the movie Interstellar. In one scene, the characters land on a planet near a massive black hole named Gargantua. Due to the intense gravity, 1 hour on the planet equals 7 years in orbit. This is not science fiction. It's based on real physics. Time dilation near a black hole could cause massive time gaps between two people depending on where they are. Think about it. Time is not universal. It's relative. On Earth, we assume time passes the same for everyone. But in the cosmos, that idea falls apart. Astronauts on the International Space Station, traveling at 28,000 kilometers per hour, age ever so slightly slower than we do on the surface. It's measurable. It's real. Let's imagine even more extreme environments. Near a neutron star, one of the densest objects in the universe, time is also significantly warped. A minute spent near its surface could equate to minutes or even hours elsewhere. Then there's the idea of interstellar travel. If humanity ever masters travel near the speed of light, relativistic time will become a practical concern. Say you take a journey to another star at 99.9% the speed of light. For you, the trip might last just a few months, but for everyone back on Earth, decades could pass. You'd return to find your loved ones aged or gone, while you've hardly changed. This time dilation is not just an inconvenience. It's a profound reminder that time is not a constant across space. It's a fluid, malleable fabric, stretched by gravity and speed. And when we consider life beyond Earth, whether in future colonies on Mars, moons of Saturn, or hypothetical planets orbiting distant stars, we have to think beyond Earth time. Even our definitions of a day and a year become meaningless. Each world has its own rhythm, dictated by its rotation and orbit. If we colonize other planets, how will we track time? Will we adopt Earth standards or build new clocks based on the host planet's motion? On Mars, scientists have already created special calendars and time systems to help coordinate missions. They've even designed watches that can keep Martian time. In the future, a Martian might say, "Let's meet at 9 sol hours past sunrise." And that might mean something totally different from Earth. As humanity expands into the stars, our concept of time will stretch with us. New clocks will be born, new calendars will emerge, and new generations may grow up with entirely different senses of morning, evening, and the passage of time itself. It's a beautiful reminder that time is both a human invention and a cosmic reality, something we create to find order, yet something that bends and twists in the vastness of the universe. In our next segment, we'll shift into the deepest questions of all. Does time have a beginning and an end? What does physics say about the origin of time? Is there such a thing as before the Big Bang? And could time one day simply cease? Stay curious, stay timeless.